In this video we're going to have a look at forces on a slope, but in particular ones involving the coefficient of friction. So the question says here, a winch drags a log of mass 600 kilograms up a slope inclined at 10 degrees to the horizontal by means of an inextensible cable of negligible mass parallel to the slope. So that's just describing what's in the diagram. It says the coefficient of friction between the log and the slope is 0.15. Let's write that down as we go. So we know that mu equals 0.15, and the log is initially at rest at the foot of the slope. The acceleration of the log is 0.11 meters per second squared. Calculate the tension in the cable. Well, I think what we need first of all is a better diagram. So let's draw a bigger and better diagram that we can mark some forces on, because in these questions a good diagram is always key. Nice and big so that you can mark forces on, and an examiner will also look at your diagram to check that you know what you're on about. So a nice big diagram that an examiner can follow will help. Right, so we've got a force dragging it up the slope. We've got the weight of the log. We've got normal reaction force. The log isn't sinking into the slope, so the slope must be pushing back up at it. And also, we've got a frictional force, which is opposing the motion. So friction is pointing down the slope because the log is moving up the slope. So let's mark all these forces on now. So we've got the tension, T, the weight, which is 600 kilograms times gravity, so 600 G. We've got the friction, that's moving down the slope, or rather resisting the motion up the slope, and it's going to be at a maximum because the object's already slipped, we're beyond equilibrium, and then a normal reaction. So the directions that we need resolving to be able to calculate the tension in the cable, like it's asked us to. First of all, let's resolve up the slope, parallel to the slope. I should really write the angle in there, which is an angle of 10 degrees. So resolving up the slope, all the forces going up the slope, we've got tension, T. Take all the forces going down the slope, so the maximum friction. And take, so the weight here is going to have a component going down the slope. And it's always 600 G sine theta. And we'll prove why that is now. So the triangle I'm going to consider, I'll do it in a different colour, is this one here, where the hypotenuse of the triangle is the weight 600 G. The right angle is here, and by the angle laws that we learned at GCSE, this angle here is 10 degrees. So we want the component that runs parallel to the slope of the weight. Well, that's this component here. This is the component that acts down the slope. So it's opposite. So it's 600 G sine 10. And I wouldn't expect you to draw this triangle every time because it does deface the diagram a little bit. But just remember that the component of the weight down the slope is the weight sine of theta. Okay, so equals mass times acceleration equals 600 A. But we've got a few unknowns here. We're told that the acceleration is 0.11, so that we can get rid of one unknown, times 0.11. So let's put some numbers in here. So T, take F max, take, and 600 G sine 10 is 600 times 9.8 times sine 10. And if we take that over the other side, 600 times 0.11, add that, so add 600 G sine 10 equals 1087.05. 1087.05. Okay, so we've done all we can with that equation now. Let's resolve now perpendicular to the slope. So we know going in that direction there's r, and the weight going in the opposing direction, so this side here that I'm highlighting now, and that's 600g, and it's the adjacent side of this triangle, so it's cos of 10. Again, don't need to draw this triangle every time. You could just remember that the weight component going perpendicular to the slope is the weight cos of 10, or the cos of whatever angle it is. Okay, equals mass times acceleration. Well, in this particular direction here, it's not accelerating at all. It's not sinking into the slope. So actually, the acceleration in this direction is 0, which means that r equals 600g cos 10 equals, so 600g cos 10, 600 times 9.8 times cos of 10 equals 5790.67. Almost there. So we know that F equals mu r now, and we're given the coefficient of friction. We wrote down earlier that it was 0.15. So let's use the first equation, T minus F max. So T minus mu r. Mu is 0.15. R we've just worked out to be 5790.67. And we know that's equal to 1087.05, which finally implies that T, as asked, equals 1087.05 plus 0.15, which is mu, times r, which is 5790.67, equals 1955.65. And if we're given the answer to three significant figures, 1960 newtons. 1960 newtons. For more videos like this, go to alevelmathsrevision.com or subscribe to our YouTube channel. If you like this video, please click the thumbs up at the bottom.